And welcome back to Algebra 1, Chapter 5, Section 5, Absolute Value Inequalities. Alright, remember, the absolute value of a number is its distance from 0. So the absolute value of negative 4 is 4, because negative 4 is how many steps away from 0? 1, 2, 3, 4 steps away. So that's a distance of 4. 2 is 2 steps away from 0, so the absolute value of 2 is 2. Okay, so absolute value is always positive. Now, what value has an absolute value? What number has an absolute value of 1? Well, we go to 0 and say, what value is 1 step away from 0? Well, we have 1, but we also have a negative 1. Okay, so in that case, x could be both 1 or negative 1. Alright, now if we want to look at inequalities, this means that the distance between 0 and x is less than 3. Okay, so if we look at it on a number line, from 0 to wherever x is less than 3. So we could go less than 3 this way, or less than 3 to the right. So this is what the graph of that would look like. Notice this is an AND statement because it's where this graph overlaps this one. Okay, so if you have less than or equals, variable on the left side, and then less than or equals is an AND statement. Okay, make sure you write that down. Important information here. This is an AND statement. Notice we have less than. Alright. Now here we go. This inequality means that the distance between 0 and x is greater than 3. Okay, so greater than 3 goes from 3 either to negative infinity, or from negative 3 to negative infinity, or positive 3 to positive infinity. So looking at this, you can tell that this is an OR statement. So if you have greater than or equals, that's an OR statement, because it can't be both of these. There's no value that fulfills both of these statements. Alright, so remember that when we solved absolute value equations, there were two cases. This in here could either be positive 9, absolute value of positive 9 is 9. Could have also been negative 9. Absolute value of negative 9 is 9. So we need to look at both of those cases. So I can either solve for it being positive 9 or it being negative 9. So I'm going to split that up into two cases and solve each one. Now they're going to solve the same way, add 4 to each side, and then I get x is either 13, 13 minus 4 is 9, absolute value of 9 is 9, or negative 5. Negative 5 minus 4 is negative 9, absolute value of that is 9. Same thing for inequalities. There are going to be two situations. Either this in here comes out to be the negative side of this or the positive. Okay, so recall, if I have a less than statement, that is an AND statement. Okay, so it's going to be either m plus 2 is less than 11, and m plus 2 has to be greater than negative 11. Now notice, I multiplied 11 by negative 1, so I had to change the sign. Okay, pay attention to this. On the negative side, when you're solving that one, flip the sign. Okay, now to solve, subtract 2. As usual, m is less than 9. Subtract this, subtract 2, m is greater than negative 13. Graph that on a number line. Greater than negative 13. And, well, the other way around. We have less than 9, greater than 13. That's going to be in between those two. This is an AND statement. Okay, and here is your solution set. Always start with the smaller number on the left, and then the larger number on the right, and x in between. Alright, to solve this, notice which way the arrow is going, the inequality sign is going. It's going to the right, so that is a greater than statement, which makes it an or. Okay, now I'm going to solve both of those. Remember, the sign needs to flip for the negative. Okay. Subtract 6, divide by 3, and we get n is greater than or equal to 2. Subtract 6, divide by 3, and n is less than or equal to negative 6. Remember, this is an or statement, so our graph is going to be pointing to the outsides. Since this is or equal to, that is filled in. Those are solid circles. So this is your solution right here. These two statements. Or if you wanted to show this in interval notation, from negative infinity not included to negative 6 included, we show that it's included by using a bracket. And then or, the union symbol, to included to positive infinity not included. Okay. Now if you want to write an absolute value inequality for the graph, remember when we wrote equations, we would take this, would find the middle, and find the distance. That's the same thing you're going to do here, just you're going to write an inequality. Now if you look at this, notice this is an or statement. You can't be both less than negative 5 or greater than 3. Okay, there's no number that falls into both of those categories, so it has to be or. So we find the middle again. The middle is negative 1. And then we find the distance from negative 1 from the middle to these points where the graph starts. Okay, that's 4 units. So it's going to be x minus negative 1. Okay, pay attention to this. This is minus negative 1. Okay, x minus the middle. And then this is an or statement, so it's going to be greater than or equal to 4. Okay, so we had x minus the middle minus the middle number, middle, and then symbol, whichever one is the right one to use, or equal, less than or equal, greater, less than, and then distance. If you don't remember that from our absolute value lecture. Alright, and that was Chapter 5, Lesson 5. Remember to like and subscribe.